right, guys, so any other... I had a couple of good questions from the homework stuff. For example, let me point out one thing. Where was that? Yeah. So I had a question earlier about this one here. Right? So that one, again, this is a really good illustration that the math doesn't care that whatever's in the problem. When I synthetically divide, I know exactly how to set it up, and I just start applying the process. We care that it's a freaking I. And of course, we have to be careful. When I do I times I, what's I times I? Beautiful, which is what? -1. Sweet. So as you go through that kind of synthetic division for number 60, for example, how would you set that up? Yeah, right there. Yeah, I, sure. So in the little penalty box would go I. And what do you put here?
101.
101. Beautiful. What's the 0 for?
The X.
There's no x's, so that's the coefficient of the x must be 0. So you must represent every coefficient of every possible term, and there's no x's, so there must be a 0 in front of it, right? Okay. And then you just start applying the process. The process can't change just because there's a certain kind of number. The process is the process. It is going to affect us as we do it, because we have to remember what I times I is. But that's just a part of knowing how to multiply complex numbers. I don't know if that helps out at all. Another question was, where was this one? Oh yeah, for example, some of these could get really big, so don't freak out if you get big numbers. It doesn't automatically mean you're wrong. Let me show you this. I can't remember how deep the book gets into this, but just to go over this a little bit. This remainder theorem means something. They don't really ask for it here, but let me show you. It's going to happen. There we go. So I want to show you something that happens. Okay, here. And then I want to understand why it happens. So let me put down here, let's say x cubed plus x squared minus 2x plus 1. Can you guys just tell me what is p of 2? It's crazy. So what do you get? 8 plus 4 minus 4 plus 1. No. You guys all with me? Yes. Oh, where was I? 5, yeah. So I will apologize, I've done this before. I know ideas, I don't always know where the hell they are, but always ask me if you're not sure what section I'm in. Let me erase this stuff here too. Now, can you all please take this and divide it by x minus 2 synthetically. If you've missed a few classes, you're not sure what the hell that means, just hang out for a moment. This will be a nice little review of synthetic division. So what's going to go in the little box? What's in the box?
2.
2. And then what am I putting here? 1, 1, negative 2, 1. Good, because I'm not missing any degree terms. Okay. So something interesting is going to happen. Let's see. This gets me started always. I bring the 1 down. 2 times 1, add. 2 times 3, add. 2 times 4, add. What's the remainder?
9 x minus 2.
No, I mean, just what's the remainder is 9. Like big ass R is 9, yes? And is that exactly what we got as the answer when I plug a 2 in? Do you guys understand what I'm saying? So okay, right now that could be a wild coincidence. I mean, look, I made this shit up. I could have just picked the one that works, right? So let me make sure you guys. So right now it seems interesting that I got the exact same answer for the remainder when I divided by 2 as I got when I plugged a 2 in. Let's investigate why that might be true. Can somebody help me? What did we just figure out? X cubed plus x squared minus 2x plus 1 divided by x minus 2. Did we just figure out what that is? What did we get as the answer?
X squared
Good, because it was cubed. Now this is squared.
plus 3x plus 4 plus 9 x minus 2.
Okay, let me stop for a minute. You guys all with me? That's what that means, right? Okay, good. So that's the basic idea of synthetic. If I just ask you to synthetically divide something, you should be able to just do it. It's a beautiful brute force thing. It's awesome. How do you interpret the answer? Well, you always go down by 1 degree because you're dividing by x to the first, right? Okay. Now watch this. Couldn't I multiply both sides of that by x minus 2? And you're like, yeah, dude, if you wanted to. So if I multiply both sides of this by x minus 2, by the way, you're never going to have to do this. I'm explaining why this will always happen. This cancels. So I get x cubed plus x squared minus 2x plus 1 equals, now watch this. I want you to see. If I multiply this by this, because I got to distribute, but I'm just going to multiply all of this by this. I'm just not going to distribute to each piece. I'm just being lazy. And what is this times this? What do the x minus 2's do? Cancels. So when I plug a 2 into this business, I have to plug a 2 into this business too, yes? What am I going to get right here? 0. No, 2 minus 2 is 0. This piece goes away, I get that. So whenever I synthetically divide something by a number, it's the same thing as if I plug that number in. So let me show you another example. This is really what the remainder theorem is. The remainder tells me something more for polynomials than normal. So what if I had, let's see, this thing, 11x cubed minus 17x squared plus 4x plus 12, sure. And I want to know what P of 2 is. I could just synthetically divide by 2. 11, 22, 5, 10, 14, 28, 40. Did that fast? Let me see. Yeah, okay. What is P of 2 then? 40. Yes, that's what the remainder theorem is. It just says, okay, these are not numbers, these are polynomials. Maybe the remainder means something more than normal, and it does. It actually means what the value of the function is at that point that I divided by. That's the remainder theorem. How important is that in the grand scheme of this class? Not crazy important, but it is a part of interpreting our results, right? In general, when I get a number that's not a 0 here, most of the time for us, that's going to suck. Why do I want a 0 there for a lot of what we're doing? Say again? Factorable, exactly. If it goes in evenly, that means I've factored it. I'm like, thank the gods, and then I keep going. If I get a number that's not 0, I'm like, shit, it didn't work. But this is just kind of showing you, hey, if you don't get a 0, it still means something. It still tells you something. Okay, maybe. Okay. real quick, a few more people came in. Anybody wasn't here yesterday? Okay. So just looking back at what we looked at yesterday, we did this here. Descartes' rule of signs. This is what I want to talk about today, is the upper lower bounds. But Descartes' rule of signs, and also just making a list of all the possible rational zeros, right? So let's do an example of that, just to remember how the hell this works. Yeah, actually, let's just do this one. Sure. So on the other side of this paper, I've already got an example here. I might as well use it. If you weren't here yesterday, you might not be able to do this, but can you take a minute and just list all the possible rational zeros? Oh, while you're doing that, Elena, I'm sorry, Alan. Elena Allen. Oh. Stephanie Morris still elsewhere. Landon still elsewhere. Aaron. Raul. Has resurfaced. Brianna. All right, let me catch up to you. How do you write down what you need in order to create all these zeros? What do you look at? Yeah, I look at the 8 and I look at the 3, right? So what are all the factors of 8?
1, 2, 4, 8.
All right, and we've talked about why this is true. We've done many, many examples of why this is true. I want to cover my ass for all the possible things that it could be. And the numbers at the end of the factors could be factors of 8. In fact, they have to be factors of 8 because that's where 8 comes from. But they could also be over factors of 3 because of the way that we solve to get the 0. I'm going to divide by the coefficient. That would be my last step. So on the bottom, I've got to put what?
1 and 3.
1 and 3, 11. So when I make all the possible ratios, I'm always going to get all of these because when I divide by 1, I just get those. But then I'm going to get 1/3, 2/3, 4/3, 8/3. Okay. Now, really quickly, I really want you to understand this. If 2/3 was a 0, what does that mean? So let's say that 2/3 makes it 0. I don't know if that's true. Let's say that's true. What factor would that come from?
3x minus 2.
Beautiful. 3x minus 2. How the hell do you do that? Well, how do I solve a factor equals 0? I move this number over and then divide by that number. So if I get 2/3, I must have had a 3x because I divided by 3, and I must have had a minus 2 because then I would add 2. You guys see that? If I had x equal to, just for another problem, x equal to 3/7, what factor would that have come from? 7x minus 3. If it was negative 3/7, all that would do is make it plus 3. Yeah, okay, good. You guys see that? Because if I solve this, I would subtract 3, divide by 7, bam. Good. Okay, so again, a lot of mathematics is thinking, what would I have done to get here? A lot of mathematics, a ton of mathematics is thinking backwards. In fact, that's all algebra is thinking backwards. Okay. So that's why I might have some fractional stuff. Now, this next thing we can do right now, how many sign changes do I see in the original P of X?
4.
Yeah, 1, 2, 3, 4. What does that mean?
4, 2.
Yeah, good, yeah. 4 or
2.
2 or
0.
0, positive, real roots. And again, if it isn't real, what is it? Complex. And if it's complex, it would come from quadratic formula. The quadratic formula is plus or minus. They always show up in pairs. So if I don't have 4 real, that means some must be complex. 2 of them could be real and 2 complex. So 4 or 2 or 0. Because anytime it's not real, it must be complex, but I must get 2 complex at a time, so that's why it goes down by 2. So it's possible that I have no positive roots, but it's also possible I have 4 of them. How do I investigate? Well, I just say to do this, but in general I would say apply Descartes' rule of signs, but what is it when I plug the negative x in? Does somebody remember the shortcut about what's going to happen?
All the signs are going to change.
Which ones?
The bottom.
Not all of them, right?
The odds.
The odd signs are going to change because when I raise a negative to an odd power, it stays negative. The even powers are going to eat that negative up. So when I plug a negative x into x to the fourth power kills it, so it stays positive. When I plug a negative x into x cubed, it's still negative at the end. Negative times negative is positive. So all of my odd powers are going to change sign. That is a shortcut. You could just plug negative x in and do the work. Or we can be more clever and go, I already know what's going to happen. Now, how many sign changes do you see in that? None. Now, this is where Descartes actually does something useful, right? There's no sign changes in that. What does that mean?
No positive roots.
Careful. Where I looked at positive roots.
No real positive.
No sign changes. No. What did we put in?
Oh,
So there's no negative real roots.
oh.
We are guaranteed that there are no negative real roots. Now, what does that mean about my list of possible roots?
It's cut in half.
Yeah, I could cut it in half. I could just eliminate all the negative possibilities. Okay. Now, is everybody kind of with me? We've talked about that. We talked about why it kind of makes sense. So that's now what Descartes' rule of sign says. So sometimes it's really powerful, and sometimes it really doesn't tell me much. It's just the way it works. Can you guys take a minute and do this? And when I say this, by the way, divide synthetically by 4, I do mean like that. But what am I actually dividing by then as a factor?
X minus 4.
Good, so be careful. When I say divide synthetically by 4, I literally mean put a 4 in there. But we understand that means I'm dividing by x minus 4. Okay. Just take a minute and do that for me, and there should be something interesting that comes out at the end. And you're like, we'll see, Jeff. Yes.
What did you do to change the signs?
Sorry?
What did you do to change the signs?
Right here?
No, when you're providing synthetically.
Did I change the signs?
No.
3, I'm sorry. What happened?
Because you got it from that.
Yeah, here's the problem.
Oh.
3, negative 7, 14. This is not the problem. This is when I plug a negative x in. So, right? Is that okay?
Yeah.
Okay. So this is not the polynomial I'm working with. This is just me analyzing with Descartes' rule of signs. this is not the function I'm working with, correct? This is what I did just to investigate how many negative roots there are. The problem I'm working with, of course, is the one that was given, right? So 3, -7, 14, -28, 8. Is that cool?
Yeah.
Okay. This here was just me investigating how many negative roots does it have. I'm not allowed to change the problem and go, I like that one, Jeff, but I'm going to make this one. All right, is it working?
Oh, wait a minute.
You know what I mean by that? Are you getting a 0 remainder? No.
Remainder.
But let's see what we do get. So 3, what do I put here? 12, good. 5, 20, 34, 136,
108,
108,
432,
432,
440.
440. Okay. So now you're like, now this is a good example. And if in the homework you can get bigger ass numbers than this. If it doesn't work, it could go insane. So on one level, it's kind of like, thanks, Jeff. Now on another level, is 4 a factor? Is x minus 4 a factor? No, we know that now. We didn't know that before. Now I know x minus 4 is not a factor, but it's like that eliminated one number. Thanks, Jeff. What do you notice about all the coefficients in our answer? I'm going to do a lot more work right now than we're going to have to do. When we do this, you can interpret that immediately. It tells you something. So watch, what does this mean? I just took that and I factored it to be, what is this? Interpret this for as a polynomial. Good, good. 5x squared, 34x, 108. Now, listen, I really want this to make nothing but sense. That's what I get when I divide by x minus 4. That's what I would get, correct? If I put a number bigger than 4 into this, is there any way it could be 0? If I put a number bigger than 4, every term in this will be positive. You with me? So this feels a lot like Descartes' rule of signs, but it's a lot more direct. If I synthetically divide by something and I get no sign changes in my answer, the number I just divided by is an upper bound, which means no number above that would work either. Do you guys understand? So if my list went up to like 60 and I divided by 4 and I got this, I could eliminate all the numbers above 4. I need you to understand this. No number above 4 could possibly make this 0, therefore no number above 4 could be an answer. So if I have a number above 4 in my list, I just eliminated it. Not only did I eliminate 4, because it didn't frickin' work anywhere near close, I've also eliminated everything above 4. That's an upper bound. That kicks a lot of ass. In this case, it doesn't kick that much ass, because what's the only number bigger than 4 on my list? 8. Okay, but I just eliminated 2 numbers with 1 piece of work. Now, help me out. Update your list. Descartes' rule of signs tells me there are no negative roots. And we just figured out that 4 and everything above 4 does not work. So take a minute and write down what the list of possible rational roots looks like now. We eliminated all the negative possibilities. We eliminated 4. We eliminated everything above 4. All right, so what do you got? Good. And then all these little fractional dudes are still there. Yes. Oh, sorry. That, and again, remember, what is this? I'm going to have to try each one of these out until I get one that works. Compared to the original list, this is much, much shorter. I cut it in half, and then I chopped a couple off at once. That's pretty good. Now, sometimes Descartes' rule of science is not going to do much for you. You're not going to find a bound. Oh well, you just got a lot of stuff to try. When I make a test or something, I make sure that's not going to happen. I kind of guide you a little bit, sort of like I'm doing here. I'll say synthetically divide by something, interpret your results, and that'll chop off a few. Are you guys kind of with me? Because the absolute worst thing that could happen with a problem like this on a test is you've got to try every single one out because you're not lucky. So you try 20 and then you find out that would work, oh thank God, and then you've wasted all the time. That's just silly. I agree, that's silly. I don't want that to happen. Does this make sense? So I do try to guide you to cut your list down so then you have less stuff to try. Okay. So now, how do I kind of continue here? What would I do next to try to factor this, find the zeros? That's basically what I just said, right? What's the next thing you could do?
Plug those things into.
Don't plug them in. Synthetically divide, yeah. So what do you want to synthetically divide by? I understand most people try to shy away from the fractions. I don't blame you. I would try the whole numbers also, right? So yeah, let's try 2. Take a minute, synthetically divide by 2. Yeah, I can't remember the answer right now. I made this a while back. So we're all finding out together. Oh, I think that works, yeah, right? So if you're in the middle of that, I think it's going to work if I did that in my head right. So let's see, what gets me started? Bring the 3 down. 2 times 3, 6. Add. -2, add. 24, add. -8, add. Cool. You chose wisely, right? Now, I want to show you something. The original problem, can somebody tell me the most obvious thing about this that tells me my old ways of factoring will not work on this? Can anyone tell me the fact that it's a 4th power, really, with all the terms there? If it was a 3rd power, I could try to group, correct? You guys see that? Because then there'd be 4 terms. Shit! Now, if there's 4 terms, does that mean grouping's going to work? No. So synthetic is still good. But let's see where we are now. So can somebody tell me right now, what did we get to work? What factor worked? X minus 2. And what did we get left over?
0.
No. I mean, I'm sorry. 0, so it went in evenly. So what did we get? Good. X squared. 12x minus 4. I love it. Now, you could, and let me just say this, you're not going to do this here, but I could take this, and dear God, listen, I would, if I wanted to continue factoring using synthetic, I would never start over here again. That would be silly. Because I've already got part of it taken out. I could just start here. So if I wanted to try 1, I could just put 3, -1, 12, -4, and then I could keep going. You guys kind of with me? Okay. But why don't I even need to do that? Do I still need synthetic's help?
No.
Because what's true about this? What will work here? Grouping. All right, good. You guys with me? So even if I say use synthetic division to factor this, that doesn't mean you have to use synthetic division all the way through. I have to do it on the first step because there's no freaking way in hell we're going to factor that first dude using the methods we knew before we did this. No way in hell. But if I use synthetic division once, I kind of analyze where I am and I go, hey, wait, grouping's going to work. I'm not going to do synthetic again because I can just factor that thing directly. Because what could be one of the answers for this is like 2/3, right? And I'm with you. I can work with fractions, of course I can, but I'm human. Fractions are just one more level that I can make a mistake with. So I don't care how good at math you are. You're not going to do a fraction if you don't have to, because that's a way you can make a mistake, because we're human. I don't have to do synthetic anymore. So can you guys take a moment, don't say anything, go ahead and factor this sucker. So what comes out of these two? X squared. And you'd be left with 3x minus 1. What comes out of these two? Yeah, so I'm trying to cut corners, but let me not do that. So let's see, x squared, 3x minus 1. I can take a 4 out of this, and I'm left with 3x minus 1. So this tells me I'm on the right track, right? So how do I factor this at the end? I got my x minus 2, 3x minus 1. X squared plus 4. Good. So this specific problem, I said find all the real zeros. Can anyone tell me just from this, what are the real zeros?
2, 1.
No. 2 I agree with. 2 I agree with.
1/3. Oh,
1/3. Yep.
1/3, yeah, that's right.
What kind of answers would this give me? Complex. Good. So in this specific problem, I say find all the real zeros. If I said find all the zeros, could somebody tell me what this gives me? Can you guys, are you at the point now where you just see what that would be? If it was x squared minus 4, it'd be x plus 2, x minus 2, I'd get plus or minus 2. Yeah, now I just throw a freaking I in there, right? So the beautiful thing about sums of squares, if I know how to factor their difference of squares, I just throw i's on them. X squared minus 4 would be plus or minus 2. X squared plus 4 is plus or minus 2i. Say again?
I squared is negative 1, right?
I squared is negative 1, yes. Cool. So again, this specific problem, I didn't ask for this, but if they do ask for this, that's how you do that. Okay. Let me stop for a minute. This is plus or minus 2i, by the way. Got a little smushed.
If it was, is when you square root the 4, would it just include 4 2i?
So again, if you were going to solve this, you'd say x squared plus 4 equals 0. Subtract the 4. That's where the I comes from, right?
Oh, okay.
Yeah. That's why sum of squares are freaky, because if I try to solve them directly, I'm going to get square roots of negative numbers. Yeah. You guys see that? If it's x squared minus 9, when I go to solve that, the 9 becomes positive. Everything's great. That's why difference of squares are nice. Sum of squares a little bit freakier. Okay. How you guys feeling out there? Yeah, that I can agree with, but in terms of understanding. Okay. All right, so let me make a more complete picture of this bounds idea. So the way upper and lower bounds work. If I synthetically divide something, blah, 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 blah. If I synthetically divide something, let me be very specific, by a positive number, just like we did a minute ago, we divided by 4, right? You guys all with me? If the answer I get has no changes in sign, that means the number I just divided by is an upper bound, which means I can cancel all the shit that's above it. That kicks a lot of ass. That's why what I do when I have this big ass list of things to try, I pick a number somewhere in the middle. Because there's a decent chance it's going to be like an upper bound. I don't know if that makes any sense for you guys. So I'm not going to pick, if I had to go 1, 2, 4, blah, 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 up to 60, I'm not going to try to synthetically divide by 60. It might work, but, you know, I'm going to pick something in the middle because maybe it's about and I can throw everything else out. I don't know if you guys are with me or not. So I'm trying to give you an idea. Do you all understand that these problems are going to involve you making a list and checking them until you get a 0? Does everybody get that right now? So everything I'm talking about right now with Descartes' rule of signs, with balance, is to help us freaking get that shit less. I want to have less work to do, dear God, Jeff. So do I. So if I try to divide by any positive number and the result's all the same sign, I can kill all the numbers above that. You guys kind of with me? If that number works or doesn't work, if everything in the answer is the same sign, I can just eliminate everything above that. So if I get all the same signs, it could be all positive, all negative. If there's no sign changes, then this number is an upper bound. Yes?
So if you get like one sign change, would you go like down a little bit, or?
Oh, I see what you mean. Yeah, this is interesting. If I got one sign change, I would go up a little bit. But I mean, that's getting a little too in the weeds. But yeah, if I divided and I got one negative and everything else is positive, you actually would go up a little bit. So let me give us a specific example. Let's say that my list looks like this somehow. Do we have an idea in mind? Sure, Jeff. 12, 24, okay. Right, that's my list. Let's say I synthetically divide by 6. And my answer is nothing but positive numbers. That means I can kill all of these, right? All the positive, I gotta be careful. I can kill all the positive 8, 12, 24. You guys kind of with me?
No.
Huh?
No.
Oh, okay, good. All right, as long as eventually you're with me, that's good. Okay. Now, the same thing happens with lower bounds. If I synthetically divide by a negative number, blah, 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 and I get alternating signs. And I want to point this out. The problem we just did, do you see how it had alternating signs? Right? Didn't the signs alternate? Didn't that end up meaning no negatives? That's exactly the same reasoning. If I divide by a negative number and I get alternating signs, that's a lower bound. I could kill all the numbers below that.
Wait, can you say that again?
Sure. Let's do a specific example. Let's do this. I'm not going to be able to move on the fly. Let me think. Sure, I actually could. Let's see if I can do this. 2x cubed plus x squared plus 3x plus 10. Okay. All right, this is going to be exciting because I'm just making this up out of nowhere. What's my list of possible rational roots? Plus or minus?
1, 2, 5.
1, 2, 5, 10. That's a good start.
1/2.
So my list of possible rational roots would be plus or minus 1, 2, 5, 10.
1/2.
1/2. 2 over 2 I got already. 5 over 2 is new. 10 over 2 I've got already.
Where do those numbers come from again? The 1/2 and
So what's on the top? Factors of this. What's on the bottom? Factors of this.
that's it? Oh.
And then how do I get the list? I make all the ratios that I can. So what I do is I take all these divided by 1, bam, and then I take each one divided by whatever other numbers I have down there. You don't have to list it if you've already listed it. So like 10 divided by 2, I've already got that. Okay. Now real quick, what does Descartes' rule of signs say about this? Can you guys just see? How many sign changes are here? None. So therefore, there are only what kind of roots? No, there are no positive roots. There are only negative roots. So what does my list look like now? Negative 1, 2, 5, 10, 1/2, 5/2. Okay.
All pluses, they're only negative.
Yeah, this should work. Yes, I think so. Well, let's see. Let's find out together. I just made this up. So let me see. Let me divide by -5 just to show. Sorry.
Yeah. All pluses mean no positive.
If I see no sign changes,
Oh, no sign change.
that's no positive roots. Yes.
So they're all negative.
There would still be no positive roots. Yep. So Descartes' rule of signs is all about how many times does the sign change. Yep.
But if it was p of negative x, then there would be.
That's how you investigate negative roots, and it's still how many times does the sign change.
Wait, so why are they now all negative?
Say, oh, because what did we just figure out? How many sign changes are in the problem?
0.
So there's no positive roots.
Okay.
So I can just eliminate them from consideration. Yeah. They've already lost the contest. They're not allowed to be in. Okay. Oh, let's see if I made one that works the way I wanted to. I think it will. So I'm going to divide by -5. Somewhere in the middle. Maybe. Would -2 work? Maybe. But let's try this. Bring the 2 down. I'm just going to kind of do this quickly a little bit. All right. I think that's roughly right. The answer, what's true about it? Do the signs alternate?
Yes.
And I divide it by a negative number. What does that mean? It's a lower bound. So not only did -5 not work, correct? So I can eliminate it from consideration. The fact that these change signs means I can eliminate what else?
Everything below it.
And what's the only one below -5?
2.
No. -2 is above -5. What's the only other thing?
10.
-10. There. So with one synthetic division, I eliminated 2 things. -5 didn't work because it wasn't a 0. And -10 can't work because -5 is a lower bound. Nothing below -5 will work, and I know that because the signs changed on the answer.
-5 is gonna work. Cross out 5 and 10.
Yeah, and since -5 is a lower bound, I can cross out anything that's lower than -5. Okay, yes?
Wait, thanks, when they kind of, how do you know if it's lower down?
When I divide by a negative number
Okay.
and the answer alternates signs, then I know there can't be any negatives below that. Also, -5 didn't work, so I can rule it out. Okay. Is that cool?
Right, so there's a sign change. So it's
No, no, no.
What?
They are alternating signs.
Okay.
Positive, negative, positive, negative.
So they're alternating signs, which means it's a lower bound. So any number lower than that is
Won't work.
Okay.
Yeah, so let me see. Let me see if you guys
Alternating.
help me out. What does this answer look like?
2x cubed squared plus x. Oh wait, plus minus 9x
9x, yeah.
plus 48. Oh, -2
What goes down here?
x plus 5.
Good. Okay, because they divided by x plus 5. If I look at, so let's say this is f of x. If I look at f of -x, when I get this, roughly, this is maybe minus, but it doesn't matter. How many sign changes do I see in this?
All of them are the same.
So therefore, there would be no negative roots that would make this 0. There'd be no negative numbers to make. There'd be no negative roots of this. That is why, when I see alternating signs, when I divide by a negative number, that's a lower bound. Nothing below that will make this work.
Same signs and a negative. Right?
Okay. And again, you don't have to do this. You just have to interpret when you see the signs changing and you divide it by a negative, that's a lower bound. If I see the signs remain the same and are divided by a positive number, that's an upper bound.
So is it any sign changes or alternating? sign
Alternating,
changes? Okay.
yes. See the sign changing from,
Yeah.
okay. All right, so coming back to the handout. Let me see. Say again? All right. Let's see, where did I put you? Shoot, all right. Well, let me put this one. So, coming back to this one, I'm not sure what I've done. Oh, there it is, right there. Yeah, okay, we finished this one, that's right. So that was, remember we did this? We got all the same sign. There's no sign changes. We divided by positive. That's why that was an upper bound. So 4 is an upper bound. And again, you need to enjoy the fact that there are things I can see that will eliminate other possibilities, because that's what I want. I want fewer things to have to synthetically divide by. Yeah.
Sorry, hold on. You said
Yeah.
4 is an upper bound.
Just a second, dude. Yeah.
So if they were all negative, it would be lower bound? If like all the answers.
If I divide by a positive number and I see no sign changes, it's an upper bound. If I divide by a negative number and I see alternating signs, that's a lower bound. Good, good, good. Sorry, go ahead, Phil. You're good?
I'm trying to write this down.
Yeah.
If I divide by a negative number, and I see alternating signs.
Yeah, okay.
It's normal.
So here, let's try this one. All right, guys, go ahead and try to get as far as you can with this, and then I'll catch up to you. Feel free to work with people near you if you want to.
Sure.
The actual division step, I want to show you something. So to create this, and again, we talked about why this works. But to create it, you take the factors of this, divided by the factors of the first dude. So I'm always going to get these guys, because they divide by 1. And then what else do I pick up? Okay, 1/2. And then everything else, 2 divided by 2, 4, I've already got everything else, right? They're all even, I've already got those. Do you see what I mean? 4 divided by 2 is 2, I've already got that. 2 divided by 2 is 1, I already got that. I know, I'm not done. Just looking at 2, right? Just looking at 2. It doesn't give me any new stuff. So I move to 3. So now I get 1/3, 2/3. Say again?
What about 2 over 3?
We're doing 3 right now. There's 2 over 3 right there.
Oh,
Yeah. So I was talking about 2. When I divide by 2, I only get 1 new thing. When I divide by 3, I get a bunch of new things. When I divide by 6, do I get anything new? 1/6, and then everything else would reduce to something I've already got, right? Except for, well, yeah, everything else I have reduces to something I've already got. Cool. Let me stop for a minute. So we talked about why that's true. So now that's just a way that we can construct. Those are all the possible fractional or whole number answers. Now we do a couple things to try to hopefully cut that list down, because there's a lot in that freaking list. So in the original P of X, how many sign changes were there? 4. So what's that mean? 4 or 2 or 0, positive real roots. P of negative X, the shortcut is all the odd powers are going to change sign. Because when I raise a negative number to an odd power, it stays negative. How many sign changes do I see in this? No sign changes. So therefore, how many negative roots are there? Real roots. 0 negative real roots. So already I cut my list in half, right? Because this looks long, but remember it's twice as big as it looks. Because they're all positive and all negative. Let me stop right there for a minute. So in general, Descartes' normally not going to be this powerful, right? You normally have like 3 or 1 positive, 4 or 2 or 0 negative, so it's like it doesn't really help too much. But in that case, if it was 3 or 1 positive, 4 or 2 or 0 negative, I might try the positives first because I'm guaranteed one of them works. Does that make sense? It still kind of gives me an idea of what to try. Or if you're a gambler, you try the negatives because it could be 4 of them work. What did you guys get when you divided by 9? You got some big ass numbers, right?
Yeah.
So let me show you what I kind of do. 6, then I got 54, 5, 45, 173.
1557.
1441.
Oh, wait.
Huh?
No, that one's
1557,
1557.
1441. Now watch this. Big ass positive, big ass positive. I don't care. Do I care what the number is? It's not 0, correct?
Correct.
It's positive. That's all that matters. If it's not 0, all that matters is what sign is it? Because now, what do I notice?
All positive.
They're all positive, which means
Upper bound.
9 is
An upper bound.
an upper bound. And yes, I understand 9 was not in our list. I understand that. But 8 didn't work. So I had to choose 9 to make this do anything for me. So what is that now? What does our list look like?
16's going.
Yeah, so it's 1, 2, 4, 8. And then all the fractions, right? So then you're like,
Oh, wait, no, it's positive because you eliminated.
yeah, so no negative roots, right? I don't put plus or minus. You with me? That still looks like a long list, but it's a lot shorter than it was. And I understand that you're not going to pick a fraction necessarily to start with. I don't blame you. I wouldn't either. So what did you guys, anybody get to this point and try something?
I tried 4.
4? Did it work?
Yeah, or
It worked. Kick ass. All right. So let's try 4. Let's see, where am I? Oh, there. 6, negative 49, 128, negative 116, 16. Just become a plus. So let's see, 6, 24, negative 25, negative 100, 28. Oh, what is that? 112? 112? Negative 4, negative 16, 0. Yay. Now watch. Let me okay. Dear God, let me make sure you guys all understand. I could write what that means. Can you guys see that grouping wouldn't work? I don't know if you guys, do you have to write it as a polynomial to see that grouping would never work for this? This would be 6x cubed minus 25x squared plus 28 minus 4x. Grouping would not work. So that means I must continue synthetically because I can't use an old factoring method. Dear God, don't pick another number and write this shit down because I've already factored it to here. If I said factor 18 and you say 2 times 9, I say that's not done. You don't start over at 18. You take the 9 and you work on it. Does that make sense? So here's what you could do. Did somebody else get another number that worked? 2. I'm going to put a 2 right here. I'm going to keep going. Right? So you work with what you've got now. I've already simplified it. What did we get to work? What already worked? What factor? No. I mean, right now, all I got to work is 4. And what's that relate to? X minus 4. Kick ass. So now we're seeing if x minus 2 works. Bring the 6 down. 12, negative 13, negative 26, 2, 4, 0. So did 2 work?
Yeah.
Yes. Now, real quick. Whatever the hell this is, I'm not going to do synthetic again because it's quadratic. You guys with me? How do I know that? It was a 4th power. This is 3rd power. This is second power. So this is quadratic. Either it's factorable or I have to use quadratic formula, right? It's just to show you. real quick, guys, I need you to understand this. The only time you throw a number out is if it doesn't work. 2 worked, correct? Do I throw 2 out then? As a possibility? Because can't 2 have a multiplicity higher than 1? Can't 2 work more than once?
Yes.
Now, I'm going to do something right now that I wouldn't do. But let's synthetically divide what we just got by 2 again. So that would be 6, 2 times 6 is 12, -1, 2 times -1 is -2. That worked. So I got x minus 4 to work, I got x minus 2 to work, and then I got x minus 2 to work again. And then what am I left with? So let's see. 4th power, 3rd power, 2nd power, 6x minus 1. So if I just write these in a row, that is this sucker factored. What's the multiplicity on x minus 2?
What?
What's the multiplicity of 2? 2, because it worked twice. So what would the power be on x minus 2? 2nd power, because they got 2 of those suckers. Do you see that? It worked twice. That's why the multiplicity is 2, yeah.
How did you know you could do it again?
In general, you can. I knew it because I kind of worked on it already. But I need you to understand, just because it works once, don't cross it out. It could work again. So if you get 1 to work, I'm going to quickly try 1 again, because 1 is the easiest freaking thing to do, yes? 1 is the best number. And if it doesn't work, then I can cross it out, because then it's like used up. But if it works once, it could work again. If it works twice, it could work again. It could have a multiplicity of 3. So this could have been, 2 could have worked 3 times. I don't know if you guys are with me or not. So I just want to be careful. Don't throw a number out because it works. Only throw it out if it doesn't work. Yeah.
For the quadratic equation,
Oh, yeah. So the way I really would have done this.
I have a question.
Yeah, go ahead.
We would have gotten 2 zeros, right?
Sorry?
We would have gotten 2 zeros by factoring. So why on dividing it again when we only get 1 0? No, so like 6x minus 1.
Yeah, okay, let's see what this is. Oh, wait, you mean here?
Yeah, the first, if we didn't keep going, we would have got 2 zeros.
No, right here, these 2. Yeah. We would have gotten these 2.
Oh, okay.
Yeah. So right here, what would I have done instead? What is this? Is 6x squared minus 13x plus 2. Can you factor that? 6 times 2 is, whoa, and then factors of 12 to add to be 13. 12 and 1, they're both going to be negative. I like it. 6x squared minus 12x minus x plus 2. I'm just going to do this really quickly. You should all be able to do this. Take a negative 1 out. And I get exactly what we got here. I got this here. Same thing. Okay, so synthetic division is doing what we would do anyway. It can just handle much worse things. I can only factor something up to like grouping. Beyond that, we're dead until we learn synthetic. Now with synthetic, we could do anything that's factorable, we could do. Okay. I know some of you guys are like, I didn't need it. Yes, you did. You're taking this course. For some reason, you need it. Okay. Yeah, let's see. Okay. I don't want to go into the next thing, but let me think. Are there any questions about what just happened with this? And just to let you know, on a test or a quiz, I would list all of these. These would all be like A, B, C. I kind of guide you a little bit. You still have to know how to synthetically divide. You still have to know how to interpret things, but I don't just say, do this. And then you have to remember all the various things. I'm going to ask you, what does Descartes say? I'm going to ask you, divide by this, what do your results mean? That's probably a bound then, right? That's why I put it there. You guys kind of with me? So I do step you through it a little bit. Okay, yes?
So would it be x minus 2 squared?
Oh yeah, so if I collect all this together, if I collect all these things together, let me see how I can put this. I would get x minus 4, x minus 2 squared, 6x minus 1.
Oh, Oh, so we're taking all of them.
Yeah.
I was thinking that we were only getting the zeros from the last one.
Oh, no.
Okay.
Yeah, every time something works, that is a factor of the original problem. So this means that to factor this, it boils down to there. Now, because you guys aren't already excited enough, I could then say, what are the x-intercepts? Well, we know it, right? What are the x-intercepts?
4, 0,
Huh? Yeah. 4, 0,
2, 0,
2, 0,
1, 6,
1, 6, 0. I love it. What does it do at each of them? No, which one does it turn at? Or bounce, whatever you like to call it. What's the only one it bounces at?
2, 0.
Yeah, because it came from an even multiplicity, right? So would it bounce here? It would go through, it would go through. Do you see what I'm saying? So the last test, I gave you something that was already factored. So a real problem would start not factored. You might have to use synthetic division to factor it, and then you can just do all the same steps. You can get the intercepts, you can see what they do at each root, you get the y-intercept, then you can plot it, you can get end behavior. What would the end behavior be of this thing?
up,
Yeah, the end behavior would be like that, because the highest degree is a positive x to the fourth, right? Do you guys see what I'm saying? So this whole thing about synthetically dividing is like, could be the first step in a problem. Just to make sure you really, really hate me. Okay. You're like, all right. Normally we're not going to kind of do all of that. I mean, that's a lot for one problem. But. So if you haven't tried 5 for a homework out yet, you desperately need to. That's just synthetic division by itself. So last thing for today. I see all you guys getting ready to leave. We're not done yet. I'm going to just lean in hard to my evil math teacher persona. Just a little preview of what we're getting into next. Okay, so let's say I have this. You all agree this is a ratio of 2 polynomials? You guys agree that's a ratio, yeah? It's a ratio. So we call this a rational function, just because it's a function made up of a ratio of things. Can anybody tell me what inputs I cannot use? -4 and 5. Cool, right? Why can't I use those? Because then I'm dividing by 0. So graphically, something weird has to happen close to -4 and close to 5. Does that make sense? If I'm not allowed to use those numbers, visually there must be something weird happening there. Does that just make sense on the surface? We might not know yet what it is, but at least I know something weird's going to have to happen, right? So obviously these problems would start off not factored, so the first step would be to factor them. Can anybody tell me the x-intercept of this? Yeah. How do I make a fraction 0? The top has to be 0, so I can see that the x-intercept is 3, 0. Can anyone tell me what the y-intercept is? How do I always find the y-intercept? Plug in 0. What do you get? On the bottom you get -20. On the top you get -3. So you get -3 over -20, you get 3/20. Right, so that's this. I don't care what the function looks like. How do you find the x-intercept? Make y 0. How do you find the y-intercept? Make x 0. Always. So you can always find those the same way. It's a different looking function. Who cares? Right? It's always the same way to find those. The next thing would be, what the hell happens at -4 and 5? So, yeah, I get it. Let me look at a slightly easier function for a second. Okay, what's the domain of this function? X can't be 1. Okay, so graphically, I can't have my function go through an input of 1. It can't go through that, right? So help me out. Who's got a calculator out and ready?
Me.
Somebody, okay. So let's investigate. Here's something kind of cool. I love this idea. Am I allowed to plug a 1 in? No, right? Everybody agree? I can't plug a 1 in. So in general, in fact, I kind of relate this to, have you guys ever seen the movie called The Blob? I'm a big horror movie fan. So back in the 80s when they knew how to make movies. So in the beginning of the movie, there's this guy, he sees this thing crash land and this little thing kind of crawls out, this little blobby thing. And he, the crazy ass guy, gets close, which I don't get close and go, what the hell? But then he touches the damn thing. So, what's this got to do with this? I'm not going to touch 1. I can't put a 1 in. I'm not going to use a 1. But I can get really, really freaking close to 1 and go, that's weird as shit. I'm going this way. So, what number is, give me a number very close to 1.
1.01.
That's very, okay, I like it. Let's start with 1.1. Y'all agree that's pretty close to 1? What do I get when I plug that in? Yeah, good. 1 divided by 1/10 is 1 times 10. I get 10. Now let's try 1.01 like you said. What do I get when I plug a 1.01 in? What is 0.01? That's 1 over 100. So 1 over 1 over 100 is 100. What seems to be happening the closer I get to 1?
It gets bigger.
It gets bigger. So graphically, as I get close to 1, the outputs, so at 1.1, the output is 10. At 1.01, the output is freaking 100. So graphically, it seems to be doing this, which relates to an asymptote. You guys heard of asymptotes before, yeah. So basically, at 1, there's a wall. There is a wall at 1. Why? I'm not allowed to go to 1. So being the horror and sci-fi freak I am, I always think about, pull up, it's a trap. So the shield's still operational, they have to pull up, so it goes like that. Or they have to pull down, they go, oh shit, right? Does that make any sense? Even if you've never seen Star Wars, you're fine. Okay, so I could investigate from the other side. I could put 0.9, 0.99. You guys kind of with me? All right, so we'll pick up there next time. That's enough. I'll free you guys.
So on the problem we just did, you want to synthetically divide until you're able to group, essentially.
Oh shit, did I start this up again? Yes.